Greetings, this is Artie from Artifact Electronics. In this episode, we'll be looking at a vacuum tube tester. I recently came across this and thought it would be a fun project to look at. I must admit I don't know a whole lot about vacuum tubes, so this seemed like a challenge for me to first of all get the tube tester and along the way learn a little bit about tubes. Now this guy was pretty much filthy as usual, but you've heard that from me before, but this one was extra filthy. It was, I mean, you couldn't even see the meter on this thing. It was so bad. So I basically used about half a bottle of window cleaner, a toothbrush, and several old towels cut into small pieces to just spray the faceplate, brush it, and wipe it off. It still is dirty, it still is pitted, but it looks a lot better than it did when I got it, and at least now I'm not afraid to touch it anymore. This particular tube tester is a Hickok TV-3/U. These were made for the military, and they had slightly different models that had the same function for civilian use, but the military ones were only sold to the military, obviously, when they were new, and I think that they had better quality components in them because everything in here had to be military spec. The switches are still solid, the interior, as we'll see later, everything was laid out rather nicely. But this one wasn't treated too well. There's a lot of rust on the hinges, the pitting of the front panel that I already spoke about, and in the background you can see the top lid showing you the olive drab color that it was supposed to be, but what someone did was they banged it up so badly they spray painted it black and then proceeded, of course, to mistreat it again, and so this thing is also has lots of scratches and stuff on it, and later on in the episode we'll talk about what I'm planning to do about the exterior appearance of this. But this particular one came out in 1949, and reading up on it, it is one of the better tube testers. One of the downsides is that I didn't realize is it's got a roll chart down here where you look up a tube specs, set all the selectors, and then press the appropriate button, which will deflect the meter, and you can look up if the meter deflection tells you if the tube under test is good or not. But the problem is with the roll chart is this thing is so old, a lot of not current, but a lot of the more modern tubes were not represented here. But what I found is that there was, a few years later, they came out with the model TV-10, and that model came out in 1957. And you can actually use the roll chart, which is printed in the newer device's manual, and with a little bit of button translation, you actually get all of the parameters for the newer type or the more modern type of tubes. So that one got solved relatively easily. The quick and dirty on operating this is you plug your tube into the appropriate socket. You set up all of these rotary switches here and here to the proper parameters as mentioned by either the manual for this or for its bigger brother, and then you press one of these buttons to perform a test. This the most important part is you do a mutual conductance test, and by observing the meter they tell you what the minimum value is supposed to be, and if you exceed the minimum value then the tube is supposed to be good. This is not an exact or accurate test by any means, but it's a really good way to do a go-no-go test on a bunch of tubes, because on a tube you can't just rely on the heater filaments being lit up. So the idea of, hey, the tube lights up so it must be good doesn't apply, because when you see the heater filament light up, it doesn't tell you anything about what's happening with the plate and the screen and all of that good stuff. This, however, will not only will obviously not work or show non-operational a tube where the heater filament doesn't work, but it'll also test the actual electronics inside and give you a gain factor or the mutual transconductance, and for you to know how good this thing is. I didn't go ahead and jump in and turn it on and just turn dials on it for the following reason. The power cord, as you can see, is severely frayed and in several places falling apart. Now if you look at it closely, you can observe that it's the outer insulation layer that's gone completely brittle and is falling off. But it's probably not a really smart thing to handle, to run it with this power cord and to handle it. So that the first thing I actually did was I replaced the power cord. And once the power cord was in, there is a very quick check on this. You press a button labeled the line adjustment, keep it pressed, and then adjust the line adjustment with this pot here, because essentially this thing wants to have 93 volts on the transformer primary. And by adjusting this, you know you're adjusted right when the meter is dead center. And when it's dead center, then you supposedly are at 93 volts. And I actually went in and measured the transformer primary, and it was very, very close to 93 volts. It was like 92.4 or something. And with the button in this position, or the knob in this position. But the one thing that I immediately realized was that the meter wasn't working right. It was deflecting a little bit, like up to here maybe, and then it was getting stuck. It wouldn't go further up, and when you turned it off, it wouldn't come back down either. I mean, eventually it would if you tapped it and all of that, but I had no way of telling whether my line adjustment, which is the prerequisite for doing anything on this, was working. So, of course, I had to take it apart, and we can have a look inside and see what got done with the meter. The meter was acting up in that when pressing the line adjust button on the tester, which you're supposed to use to center the meter, and what would happen is the meter would deflect to approximately here and then get stuck. Even when you turned off the tester itself, the needle would linger there. It would not go higher than there, and it would just stay there. And if you tapped it a little bit, it would essentially very slowly come back down to zero. So I went ahead, I disconnected the meter and removed it from the tester, and I also took off the case of the meter and with the front window. And it turned out that the mechanism was lazy. I mean, it didn't want to go, and at first I thought I was done for with this meter. And I looked inside. There's some very fine springs, wound springs in there that control meter movement, and they were very, very delicate. I could not go in there, and I kind of guessed that it needed a cleaning, but I could not get in there. I even tried some very low pressure air, and the air would distort all of the springs in there. So if it wasn't already broken or ripped off, I was going to do so using air. I did observe the springs, and they looked to be intact. So my last way out is that I submerged the lower part here into IPA. I let it sit in there for a while, for about 10 minutes or so. I took it out and then let it air dry and the IPA fully evaporate for about an hour. And the meter started to move. So the meter now will move all the way up and come back down again. Then, the next test was that I wired it to the tester. And the first thing you're supposed to do on the tester is, once it's turned on and I guess tube's warmed up, is you're supposed to press the line adjust button. And what that does is it needs to have the line voltage adjusted to 93 volts on the transformer primary. But there is a big pot on the front of the tester marked line adjust. So what you're supposed to do is press the line adjust button, and once you do that, then adjust it until the meter is centered. Now, in this case right now, the scale is loose because I had disassembled it, so it's not exact, but we can test to see if that part works. So if I go in and I press the line adjust button, it does in fact go up, and I can adjust it with the line adjust pot. So it looks like I've brought the meter back to life. It also goes back to 0 now. And since it's so delicate, I should probably put it back together and see if it still works with the case on, and if I can zero the meter and adjust everything correctly. Here are the guts. I mean, this is the front panel here, and everything's mounted on the back of the front panel. And when I took it apart, there were 10 screws around the perimeter that held the panel to the case, and of those 10, 6 were missing. So obviously somebody's been in here, most likely because of the meter, which is over here. And but I guess they gave up and put it back together, put some screws in, and left it at that. But the power cord replacement was very easy, right over here, just new wire and a new plug. If you look at the inside of this, you can see the roll chart in front here, and the only active components inside this are these 2 rectifier tubes, and everything else is just a big huge matrix of rotary switches that just route the appropriate signals to the appropriate sockets that are on the faceplate. And some of these rotary switches, I mean, you can see there's smaller ones, bigger ones, and the king-sized ones back here. However, when I had it open like this, I powered it up as I was doing my visual inspection, and I immediately noticed that this rectifier didn't light up. So, you know, it was kind of a catch-22 because I couldn't test it because this is the only tube tester I have. But one thing I learned a while ago on tube amplifiers is you have to go in and you have to clean the pins on the tube. And sometimes if the tube fits in too loosely, you have to retension the pin contacts in here, which you can do with a small screwdriver by bending them back towards the center. The pins were tight, but I guess I cleaned the pins with contact cleaner, inserted the tube a couple of times, turned it back on, and it lit up. So that was simply a matter of dirt. Something else to note on here is right in the middle here we have a paper capacitor that will definitely need to be replaced as soon as, of course, I can get the replacement. And during my visual inspection, I came across a few interesting things. The first thing I found was the original occupant of this spot right over here, which was this. And as you can see, it has shed some of its skin. This is a 10 watt resistor, 8.5K, and what makes it unique is it's adjustable. So you can loosen the screw here and move the slide up and down, and that's basically that's the center, that's the tap on the resistor. And by connecting that to the end of the resistor, you have an adjustable resistor. Now this resistor, the manual didn't make this clear, but what it did was adjusted the overall DC voltage that are used for driving the tubes. And when I measured this, it was about 23 megs, so for all intents and purposes it had received a lot of current and decided to open up. Now this was a bit of a quandary because I could not find a replacement for this. I'm sure given enough time I will, but an 8.5K 10 watt adjustable resistor I guess is not that common anymore nowadays. So what I did was I knew what, for instance, the test voltage, the plate test voltage in here is 150 volts. And having looked at the schematic, I knew that if I had any sort of a pot, I could temporarily wire it in here and then adjust that pot until I get the 150 volts plate voltage out of it. Of course, I didn't have a 10 watt pot. I had a 1 watt pot like this guy. So, and of course it's 10K, 8.5K you won't find, but that's okay. What I was trying to do is find the closest fixed value to how this needs to be adjusted and put that in for now until the day comes where I find the exact replacement part. One thing I knew I had to be careful about, because this is a half-watt part and not nearly rated, I don't remember what the voltage was, but it was around 100 some volts sitting on here. And I'm not sure, I don't think that these are rated for that high of a voltage. So I knew that its lifespan was going to be really short. However, I wired it up and quickly went in and put the meter into one of the test sockets where the plate voltage was, and then adjusted this guy till the plate voltage was at 150 volts. I quickly spot checked like the screen voltage, which was 130 volts, and some other voltages, and they all seemed good. Then I removed this guy and I measured the terminals, and it measured at approximately 6.1K. So what I did was I replaced the patient here with a 10 watt 6K resistor that was easily available to me, and it's going to introduce a bit of an error. But for now, for me, in order to do operational tests and everything, this is going to be all I need. I started to check everything else in the electrical path of the old resistor because it obviously got a jolt of current, probably caused by a bad or shorted tube or whatever. But I did find one more guy, and that's this one over here. It's a wire wound 15 ohm 5 watt resistor. You can see some marks on it, but they were hidden from sight, so I just measured it and it was open completely. I wasn't able to find a wire wound one, so I got a ceramic 5 watt, but it's at 15 ohms, so this one got replaced. And I continued measuring resistors in there, and everything else seemed to be okay. So it was time to put things together and see if we could actually get some operation out of this. Now, one thing to add is when I was putting in the fixed resistor and measuring test voltages, these are the sockets, by the way, that you put the tube under test in, and they tell you which pins on which socket to measure for the plate voltage. And the funny thing was that all of the voltages, I mean, there's a let me see, there's a screen voltage, a bias voltage, a signal voltage, all sorts of stuff, and they all checked out. But when I measured the plate voltage, which was supposed to be 150 volts DC, it came up as 205 volts. And that was really odd because they're all connected together very closely in the circuit, and it just didn't make any sense to me how the screen voltage could show proper 130 volts DC, but the plate voltage was way high. And of course I reread the manual over and over again until I finally read the specification of the meter you're supposed to use. And it says voltage tests must be made with a multimeter or individual meters of 1,000 ohms per volt sensitivity, having suitable ranges of AC and DC. That It didn't make a whole lot of sense to me, but after doing some research, it turns out, of course, that modern meters, such as this guy here, have an input impedance of 10 megaohms. So that does not provide enough of a load. I mean, those DC voltages all assume that they're going to have a tube loading it down, but the 10 ohms didn't load it down properly. So I looked, I didn't know how to solve it, and I was having visions of having to go out and buy a 60-year-old meter, but then I read in a news group where this exact thing was discussed, and people came up with all sorts of equations and solutions, and at the very bottom of the discussion, I hit the jackpot because a guy came in and said, just take your leads and put like a 200k ohm resistor across it, and that'll bring it close enough to the 1000 ohms per volt sensitivity. I still did not fully understand it. I mean, all I really got from it was that you're obviously dropping the input impedance radically by doing that. But lo and behold, I did it, and the plate voltage now came back correctly as 150 volts, and the other voltages I had read before were still correct. So, what do we learn from this? Read the manual and follow the instructions, and especially on older equipment, keep in mind that the test instruments they had back then were completely different than what we have nowadays. As I was getting ready to reinsert the panel into its case, this fell out. It was lodged in there somewhere, and after doing some checking, this is basically a washer that goes on the other side for one of these two pots. So somebody actually went in there and did some deeper analysis and decided to drop this in there. It looks like it's anodized or something. I don't know if they anodized things at that time, but it's still conductive as hell. So if I hadn't found that, and of course you saw what it looked like in here, if it had lodged itself into, any of the rotaries over here, or the transformer over here, that would have had some really bad results. Another thing worth mentioning, of course, is that I had to use my special SMD soldering iron here. The solder joint in there won't move with a regular iron, even cranked up. And I think what the real problem is there's a coating on everything that was sprayed on after it was assembled, I think in order to, make it moisture-proof and stuff like that. So getting some of the solder joints to flow was pretty difficult. It was also difficult to measure a lot of the components, because even though it looked like you were measuring bare wire, you were measuring the coating on the bare wire, and everything was showing up as open. So you need to think differently when you're working in an environment like this than working in modern stuff. So I put it back in the case, and I got some new screws for the perimeter. They, of course, clash horribly with the existing screws, but looking inside, getting some of these existing screws out is going to require some pretty extensive disassembly to get to the nuts and all of that, and that's probably another task that I will assign to the future. And also, this screw hole is completely worn, won't take a screw. So let's plug this guy in. And do the ever important line adjustment. So turn it on. You can see the pilot light comes on. And the pilot light is also an indicator of how your line adjustment voltage is, because as you turn this thing, it gets brighter, and fainter. And I'll just set it here for now. And what we're supposed to do is press the line adjust button over here. Let's do this so you can see and observe the meter. And yeah, I'm pretty close. The meter, I've also zeroed the meter, of course. And by turning this, we can get the meter to be dead center. And you let it go, it comes back down. So for day-to-day use of this is how you calibrate it. And so the next thing we need to do is actually get a tube or two and measure them and see if this does the job. Now it's time to do a real live test. I wanted to use a known good tube. So after going through my stuff, I found this. It's a Shure tube phono preamplifier stereo, and I know that this works. So I'm going to remove this tube and see if you can see that. It's a Telefunken 12AX7, also known as an ECC 831, made in Western Germany. I think this is one of the infamous Berlin tubes that seem to be in, well, judging by prices on eBay, seem to be in pretty good demand in the audio world. But I know this is good, so let's find where it plugs in, and that's over here. And maybe we can get a little closer. We can see the tube. We can see, let's see. So the way it works is you basically look up the tube in the roll chart, and since you most likely can't see it there, I'll show you the example because this roll chart's also printed in the manual. And if we look at the 12AX7, we can see a bunch of numbers there that tell you how to set this thing up. So now going through this, it tells us that the filament voltage is 12.6 volts. Then it tells us that these switches need to be set to, where is it? EV76080. Of course you can't see it from here, but there's a little display window above these. Let's see if I can get close to that. And that actually show the value of what these switches are set at. So now all we got to do is set it up correctly to EV76080. And of course underneath it tells you what that is affecting. The bias needs to be set to 8, and there's a little marker on top which you also can't see, but I'm setting the dial to 8, and it wants a low signal. Oh, and the shunt needs to be set up to low signal also. And what else? Oh, and then it tells us that this is the test for triode number 1. It's got two to test, and that the minimum mutual conductance should be 950. And that is on the middle scale here, and 950 is approximately here. So now that everything's set up, let's turn this guy on. Make sure that the line adjustment is still good. And it isn't. So let's bump this a little bit. Okay. And I can't see the tube lighting up. It's not really getting warm, but So let's see. So in order to test it, we press switch P4, which is this. 1000 is over here, and this one is pointing at just under 2000. So the minimum was actually 950. This is a little more than twice of what the minimum is supposed to be. So I think we can safely assume that this tube is good. Now, it's a bit of a pain, to actually check the second triode on this, because you got to reset everything. But while we're at it, 12.6 volt grids, EV 2103, and everything else is the same. So now it's going to test the second triode in here, and the second triode measures about the same, comes up just under 2000, and it's supposed to be 950. So it looks like our first operational test was passed. It checked a good tube. I'm going to have to repeat this with a bunch of other tubes and make sure that everything else in here works. Now what this also does is it's also a multimeter. It does volts, amps, ohms, and capacitance. I did that. It wasn't very exciting. The volts kind of work, but when being used to a digital meter, it is just really difficult to read these scales. And especially since the scales have 3 different ranges on them, and finding the proper range and figuring out what the value is. The long and the short of it is that the volts worked, but were off by about 10%. But that could be an attribute of my eyesight. The mils worked about 5% off, and the ohms were almost dead on, and the capacitance was kind of off. But that may have something to do with the paper capacitors that are still inside of this. But I think we're done, and so let's talk a little bit about future plans. Well, it seems to work, even though the multimeter functions were somewhat off. But that, as I said, that's probably the fault of old capacitors in there. And I'm probably, it's kind of masochistic to use this as a multimeter, so I'm not going to worry about that too much. However, it's going to need to be tested with a bunch of different tubes. I need to test a tube that fits into every one of these different sockets over here. And other than that, we come to the cosmetic updates. You can see how ratty this thing is looking. I mean, the guy just spray painted it, including the plastic handle, and I don't know yet. That's probably going to be a weekend project in the future where I try to strip this. And I'm also going to have to find new hardware for this, because these are rusted pretty badly and they're not very stable anymore, including the hinges and everything. So it needs a case refinish, and the fittings need to be redone on this. But other than that, I think it works, and I can now test things. Of course, what I need now is something real to test, not just tests and taking tubes that are known good and all of that. But it just so happens that a few days ago, I was checking local ads, and it was one of those things where I found a few really good deals. And of course, the minute I called up or texted the guy or left them a message, they actually contacted me back about 10 minutes later with, oh, it just sold. Well, the first time you hear it, you go, bad luck. But the second and third time you hear it, you go, oh, this is really, really bad luck. Anyway, on my fourth try, I actually reached somebody, and I think I hit pay dirt, because what I found was a guy was selling old analog tube scopes, essentially for scrap value. He pretty much told me that he took them to a scrapyard and they offered him a few bucks each, depending on the size of the scope, and he said that if I pay him a few dollars more, he'll sell them to me. So I ended up getting 3 analog scopes, a Tektronix, a Heath kit, and a, boy, I'm going to have to look at that one. And thirdly, an Analab oscilloscope. And so now I have a tube tester. Those things are full of tubes, and in future episodes we're going to go ahead and try to fix those guys. Power them up, see what ails them, and see how much help this will give us. The last thing is I'm going to have to get this faceplate cleaned because it really bothers me. And in order to do that right, I'm going to have to disassemble it and take out the ugly screws and just have all the knobs and all protrusions gone in order to be able to really wipe this thing down. And when I do that, I may take some of these sockets and replace them while I'm at it, putting fresh ones in there. But for now, I have a working tube tester. So I hope you enjoyed this. And I think at least I learned a whole bunch about tubes. I'm sure there's some of you out there who know this stuff and who are going to point out my numerous errors that I made and assumptions about tubes. But at least I learned, I know a lot more about tubes now than I did before, and I feel more comfortable trying to repair an instrument with tubes, where the repair goes beyond observing the tubes, and if a tube's not lit, buying a new one and plugging it in and hoping that it comes back to life. And those scopes I mentioned should give me ample opportunity to test this out. So again, we are at the end. If you think this deserves a thumbs up, don't be shy. And if you haven't subscribed, go ahead. I'm sure you want to see what happens with those 3 analog scopes. See you later.